Okay, so here we are. Once again, good afternoon for everybody who is in here, and good morning for those people on the other side of the globe. So I believe we have different participants from different regions. So thank you so much for spending your afternoon with us, and we are very excited to discuss with you our topics that was prepared by our with the people from Calibrate and TeamSoft. So but before going in there, so I would like to just build up some rules. So please turn your microphones on mute. And if you have questions, you may just raise your hands, or you can also scan the QR code in this screen and put on your questions in there. Also, you can access our chat box for the questions that is bugging in your mind during the presentation. Also, this QR code will be in our slides within our presentation. So just don't hesitate to just type in your questions in this QR code. So maybe we can have this started. So anybody is excited? Hopefully our speakers are. So this webinar will focus on how the partnership between Calibrate and TeamSoft to support companies and different industries in transforming their infrastructure with our unique product, which is OSI Soft Pi system. So this partnership also hopes to enhance your data and make it relevant, giving a front seat to the future's industrial digitalization. So today, we will have our speakers from Calibrate and from TeamSoft, Isamu Shinozaki, Gabriel Marazzi, Dr. Felicia Moody, and Marco Alanteri. So stay connected so you won't miss anything. Maybe we should go to our first speaker. Our first speaker is from Calibrate. He is our chief engineer and co-founder, Isamu Shinozaki. Isamu provides Calibrate Systems Incorporated and its customers over 15 years of experience in IT hardware, software, and systems infrastructure. His expertise and experience enable him to deeper understand the convergence of operational and informational technologies, thus creating efficient and unique solutions to calibrate customers. So without further ado, let us welcome Isamu Shinozaki. Isamu.
Hi, good afternoon everyone. Magandang araw sa inyo. My name is Isamu Shinozaki. I'm the Chief Architect of Calibrate Systems Inc. And today for the next 10 to 15 minutes, I'll be introducing the Pi system, Calibrate, what we can do, and I'll move on to our partners at TeamSoft. So my presentation is called the Fourth Industrial Revolution. And that's what we call the Industrial Internet of Things. And what the Industrial Internet of Things is. But before that, let me talk about the company. Next slide, please. All right, so Calibrate was founded in 2013 to 2014 during that time. And we're a systems integrator for the OSI Soft Pi system. And what we basically do is we're very good at collecting data from your different equipment, systems, islands of information, and we're able to bring that in one place. So you have one box that holds all your operational data, and we can easily integrate that to other systems, or you can use it for data and insights, which we'll talk about during the SigmaFine presentations. So we're mainly in power and utilities, but we also have manufacturing clients as well. In the next slide. So again, what we're really good at is collecting data from your most valuable assets. you have power transformers, you have boats. I'll be talking about how valuable a cow could be to your operations. Next slide, please. So before I talk about what industrial IoT, the industrial IoT focus is, what is IoT? IoT, of course, is the Internet of Things. It's not something that's particularly new. It used to be called machine-to-machine communication, at least IoT, industrial IoT. But the Internet of Things, we're here at an age right now where everything is smart, from your phone to your other gadgets in the house. What makes a thing smart? It's able to send back information to a system. For example, being able to control your lights at home, being able to know how much power your generator is currently making if you're in the power industry. So a lot of things brought us here. Sensors are cheaper now. The boards themselves are cheaper now. So this is the era we're living in right now, IoT. Next slide. For industrial IoT, our main focus is giving you more for less. Basically, increasing process efficiency, being able to know how much power each floor of your building is using will help you realize how to cut down costs down the line. How to increase productivity. We've had customers before that we help transform in a way where users are in charge of their data. When we were starting out in the power generator scene, I remember that one recurring issue is when an engineer is in a hazardous area, and basically he needs to radio into the control center just to check if the temperatures in the next area are safe. Today, with the Pi system, he can go on his phone, check the data for himself, and it's basically right there. He's empowered to be in charge of his own safety. It doesn't need to be reactive, wherein you need to request the data before you're able to use it. It's all within your hands. Next slide. So our belief is that every data is a data company. And one of the best stories to prove this is one of our pilot deployments back in 2017, where we actually helped a Wagyu farm increase their growth rate of females. So how did we do that? So what we did is we installed pedometers on the cows, either on the necks or the feet, depende na. And those pedometers, well, they count steps. They send data back to the Pi system, wherein there's actually a research study that says, next slide. There's a research study that says if you monitor the steps of the cows, once a month, you will get a spike in the data that is the trigger for S2s, or when they're in heat. So if you monitor the steps every day, you will see a spike once a month, and that's when they're in heat. And when they're in heat, the research study says you have a 16-hour window after you detect that spike. In the later 8 hours of that 16 hours, in the last 8 hours rather, you have a better chance of birthing a female. Now, if you miss that window, you get a better chance of birthing a male. For them, their operations are in beef, so the females are worth a lot more than the males. So with this data, they maintain two bulls that should be doing the job of inseminating. But when you have 100, 150 females to one or two bulls, you're going to need tools like this to help them to help the male, to push the male to the females in heat. So this is one way that you can utilize data, in this case footsteps, to increase the production of your beef farm. Next slide, please. So it's a three-step process. Collect data, and we're very good at that. We have OSIsoft has 500, 600 different interfaces to connect to different assets and equipment, and we also support a lot of industrial standard protocols like Modbus, OPC, BNP3, you name it, we support it. At the end of the day, we can also do manual logging, but that's something we want to avoid. Being able to compile all that data, keeping it in one place, the OSIsoft PyHistorian, analyzing the data, in which we have PIMSoft here to do the advanced analytics. And what we get out of that, we get real-time insights from your different silos of data. I've met customers with easily 10 to 15 silos or islands of information, and we're able to unite all that in one system, give them one display for their entire operations, which was not possible before. Next slide, please. So the way this works is you have all your quote-unquote Pi interfaces on the left side. So again, these are your islands of data. And these could be either systems or individual devices. Like we could easily have thousands of Modbus devices on the right side, on the left side, which we're collecting data from using Pi interfaces, which are native drivers for, again, these different pieces of equipment or assets. And we also feature buffering just in case, a connection is loose when sending data to the Pi data archive, nothing is lost in the process. So after collecting data, we're storing that in the Pi data archive. The Pi data archive is a real-time data historian. And to differentiate it from your typical RDBMS, this is a lot faster. We can ingest data in the millions per second easily. And on top of the Pi data archive, so you have all the data. The next layer is modeling all that, thousands to millions of data streams. So you sketch out the hierarchy of your organization. If you're a power distributor, you may want to map this into your different substations. If you're so that's basically the way it works. It's a hierarchy of the process in your organization. And on top of that, we have analytics, which we have PIMSoft SigmaFind for. There'll be several presentations after me. So that's actually the topic for today. We have Pi event frames on top of analytics. Pi event frames allows you to make sense of your data. So if you have a pump, you're monitoring 3 parameters from that pump: RPM, voltage, and amperage. If you tell me that when the pump is operational, it would have an RPM of 3,000, a voltage of 480, and an amperage of 10 to 15. Okay. Now, once the pump is idle, RPM is maybe 0 to 50, voltage is low, amp is near 0. So if you tell the PI system that, it can help you create a pattern wherein it's able to tell you your utilization. So by the end of the day, we can tell you data such as how long you've been running that pump, how long it's been idle, how long it's been off. So once you're able to do that for your different, say you're monitoring 1,000 assets in the PI system. Once you're doing that for 1,000 things, you can then optimize how you want to save energy by just using these equipment sets, turning some things off. So, you get a lot of insights from all the data you're storing. And over to the right side is that while we're able to collect all of that data, we can easily push it to other systems like SigmaFine, which runs on top of the OSIsoft PI system. There are several display visualization suites. Of course, Excel is available here. If you want to work with your real-time data in Excel, that's very much possible. Anyway, that's technically all the time I have for now. And I hope you guys stick around for the PIMSoft presentations introducing SigmaFine. Next slide. My address here if you have any questions after the event, but I'll also be sticking around. Thank you very much.
So thank you, Isamu. That was a wonderful and interesting information. So I'm always in awe whenever he tells that connected cow story, which never gets old. It's like this innovation covers a wide array of relevance in different industries, making the possibilities limitless. That is why we are privileged to partner with PIMSoft, having the same vision of generating value for our customers by ensuring consistent accuracy and usability of process and manufacturing data, making their customers fully trust their data for action. So without further ado, let us go to our second speaker, Gabriel Marazzi. Gabriel Marazzi has a technical background in IT and IoT related to digital transformation, process optimization, and data analytics tools applied to oil and gas, refining and gas distribution, petrochemical, and production sectors. He is working as an account manager in PIMSoft and supports companies in the Asia-Pacific region in the digitalization journey through the deployment of SigmaFine. Without further ado, let us welcome from Milan, Italy, Gabriel Marazzi. Gabriel?
Hi, Erzaline, and greetings, everybody. Welcome to the second part of today's webinar that will focus on SigmaFine and its capabilities to transform data into digital assets. Next slide, please. Thank you. So today you will learn in our presentation the basics of data reconciliation through SigmaFine, how SigmaFine can support the different business in process automation, and the benefits that are achieved by our customer. Now it's my great pleasure to introduce you our co-presenter for today, Dr. Velisha Moody. She's our industry principal for power, mining, and metallurgy sectors, and Marco Lantieri, our industry principal for refining and petrochemical sector. So Our company mission is to generate value for our customer by ensuring the accuracy, the reliability, and the usability of their process and manufacturing data. So what we want to do, we want to unlock the economic value of the customer data and to help them to improve their performances during the production processes. Here is the history of our company, PIMSoft and SigmaFine. So PIMSoft was founded in 1995 and since the beginning started as OSIsoft by system distributor. Instead, the SigmaFine is a solution that was created in 1993 to serve process and improvement plan and refining. In 1999, SigmaFine was acquired by OSIsoft until 2010, when, since PIMSoft was one of the best system integrators of SigmaFine in the world, decided to acquire SigmaFine technology from OSIsoft. We funded also PIMSoft Inc. and we opened an office in Houston. In 2018, we acquired a company in US specialized on PI services and solutions, Omicron LLC. In 2020, we released the latest version of SigmaFine 4.7. And this year, in a couple of weeks at the SigmaFine Summit, we will launch the new SigmaFine Hub. So now let's talk a little bit more about SigmaFine basics. So SigmaFine is a model-driven advanced analytics software that validates and reconciles data, which streamlines and automates the process of generating usable dataset for people, business processes, and other applications. SigmaFine combines engineering principle, statistics, knowledge to maximize the value and the quality of information extracted from disparate data sources and service data, regardless of the industry or business context. So SigmaFine is an enterprise class software that transforms operation data into digital assets. But how SigmaFine enables so many industries in adopting a data quality improvement process? At first, through data reconciliation, which constrains the data with the first principle equation, such as conservation of mass, volume, energy, or components, while simultaneously minimizing the uncertainty associated with the measurements. On top of the data reconciliation, we have tracking capabilities that allow to infer physical properties, grades, steam qualities, as well as ownership and other business categories. However, SigmaFine is not only a set of advanced analytics. Its foundation is an asset database, which is fully configurable, customizable, and extensible to adapt to the needs and requirements of different industries. It scales in size from very small models of few hundred assets to very large models where are composed of tens of thousands of assets. Finally, it provides a seamless integration with the customer infrastructure, able to interface bidirectionally with disparate data sources and data repositories, such as historian, planning and scheduling system, movement system, ERPs, and business intelligence tools. The principle and concept of industry standards, such as ISO, API, ASTM, related to process data handling, can also be incorporated into the SigmaFine balance, thus often addressing corporate reporting requirements of data quality assurance. Engineering principle beyond the conservation of mass energy, such as steam tables, thermodynamics, are already available within SigmaFine. And the business concept, such as emission, losses, domestic and international tax rule, or such configuration can be incorporated into the SigmaFine solution. So how SigmaFine can transform data into digital assets? We can acquire data from different sensors from the field, from analyzer. We can get also property and attributes and material movements. We SigmaFine validate the data, reconcile the data, and in the end condition this data. The main purpose is to minimize the uncertainty. And at the end, this data can be shared with the different departments like production accounting, can be used for different analysis like quality tracking, composition tracking, and energy balance. Okay, so now I'll talk a little bit more about the Sigma Fine infrastructure. So Sigma Fine is configurable according to company business. We have different extensions and plugins that can be incorporated in the business logic. It is scalable, so we can start from a single unit to include the entire process network. It is reusable for different types of analysis. And it is also compliant with the international standard. So what is a data set? A data set is an amalgam of heterogeneous data. So through the model, we get all the data from different data types and different data sources and different data structures. We analyze this data through Sigma Fine and we generate a validated data set. Okay, so this is our Sigma Fine framework. So our solution is a model-driven solution. As I was mentioning before, we get the data from the field, so it can be receipt and shipments, meters, tanks, information, limbs, unit operation, and we create a model. A model can be simple or can be also even more complex, as you can see here. Until this one that, as you can see, is very complex and running an analysis daily can be very difficult. So we run our Sigma Fine analysis on top of this model. So when we create a model, we have to define the scope. So this model will focus on equipment on a single unit. Maybe it is on the utility system and network. It's a site-wide, company-wide. We need to define also the engineering principles that we want to apply in our model. So they are a thermodynamics principle, property estimation, volume to mass conversion, which analysis are going to set up in our system. Is a mass, a volume, an energy analysis, or is a combination of two of these analysis, mass and energy, mass and component. And at the end, we have to define the time frame. So it's nearly real time, it's a batch, it's a hourly, it's daily or monthly. So as you can see here, it's a quick summary, but of all the operations you can do using Sigma Fine on the left and the different application mandates. So as you can see, it can be very different. So site-wide material balance, maybe yield accounting, operation monitoring. So it's really customizable and flexible, our solution. And it has been applied in different industry verticals, as you can see listed on the right. Now we prepare 4 case studies, one for the mining sector, one for power generation, one for oil and gas, and the end one for the chemical sector. So I leave you to the first case study.
Hello, good morning. I'm Felicia. Let me share my screen. And so I can go through this presentation with you. So I'm the industry principal for metals and mining and power generation, let's say new industries for Sigma Fine. And I'll take you through this mass and component balance that was done at ArcelorMittal. So in ArcelorMittal, it's a very big supply chain in Canada, from the mines to the ports. Sigma Fine, however, is in the pelletizing plant, which is here, and not upstream in the beneficiation plant. So prior to Sigma Fine, everybody needs to do a mass balance, and specifically metals and mining, sorry, for the metals and mining industry, because the components are also important to balance, because this is what you really sell. And so they were doing it weekly with a combination of 5 Excel spreadsheets and a lot of macro. And the reason why it was weekly is because it took 3 days to close the balance. So they had another very big issue, which is the availability of data. So the pellets are mass, let's say solids, very difficult to measure. It's a bulk material, and they have no measurement on the output. And the inventory was done 2 times per year. So if you try to do this on a mass basis, it's probably insolvable, which is why we had to perform a mass and component balance. The digital transformation going from Excel spreadsheets to an infrastructure solution involved the SigmaFine balance, which is really connecting your measurements. You can see we have a flow, we've got input, output, we've got a mass flow, as well as an analyzer. This is in the PI, the OSIF, let's say, client interface. And on here you can see the components that we were balancing. We were balancing iron, silica, calcium oxide, magnesium, coke, which was not yet done. This, of course, changes with industry. So if we're in gold, silver we are using, and those components of interest can also be impurities. So SigmaFine, as Gabriela mentioned, it's really connecting all your measurements, both mass, analyzer, volumes, as well as inventories, and it is applying a minimization to get rid of the inconsistencies. So in is equal to out minus changes in inventory. What did it look like at ArcelorMittal? They drew a flow sheet. In the AF, they have a very small view of one connection, and then they use PyVision to share the full model to the organization. As you can see, it looks very similar to the flow. But in terms of making decisions, we also have an SQL backbone on SigmaFine. And so with the models of the SigmaFine AF model, mass and component balance, they also have some operational efficiency models at ArcelorMittal. They were able to create this kind of overview of the production, so they could see the total production, they could see the performance on line A and line B and so forth. Red indicates that they are below target, and they can drill down and see the history of the performance of this asset. So they really merged the production accounting, considering metals and mining, as well as the asset utilization. And this was able to be, this is done daily, and they can share it with a link. So basically they move from reacting weekly, 3 days delay to in the morning, the manager has all of this to make the decisions for the next day in terms of setting new targets as well as planning. Just because I know that we have a lot of PI persons in the background, on the back end of seeing of this kind of output, they had AF servers for the SigmaFine and also for the process. They also use the asset framework, as I mentioned, one for the model, one for the OEE, and the event frame you can think of, or mass balance. It's a daily context. It's like an event frame. They also use the event frame on the assets in terms of running time, etc. And they use kind of notification for 2 things. One, when the SigmaFine imbalances are high. So instead of searching for the errors are presented to you, so you know exactly where your data is out of spec. And also on the input data. So PI notification on the reconciled data, and also PI notification as well as on the input data. Visually, that's what it looked like in terms of, you can see there's Spotify. There's not just SigmaFine and PI, and SigmaFine being AF friendly and compliant, let's say, and Microsoft, they're both our technology partners. We can expose our data in quite easily in these visualization tools. So in a nutshell, ArcelorMittal moved from a single spreadsheet. They moved towards an AF solution, which now it's a process. It's not one production accountant doing the job. They moved from weekly to daily. The model is auditable. There's an audit trail. It is aligned to the process. And the imbalance gives them opportunity to make new projects. In the interest of time, I'm going to move to power generation. This case is close to home, as this was my project. And Uniper came to PIMSOF many, many years ago, when they were called Aon. And they came to us because from a financial perspective, in the Netherlands, they need to validate their financial data. And here you can see that we have hundreds of financial data and perform internal data that needed to be validated hourly. Now we're in power. A day is too long for a time interval. And before SigmaFind, they had 5 engineers that were doing the balance, checking the data quality, validating the data for a financial perspective, and also taking care of the assets. To do that, this is what a part of the job entailed, lots and lots of Excel. So it's not just lots of columns, but there are lots of sheets, and this is for one site. So you can imagine, and we had 4 sites to do in the Benelux. And maybe another thing that happened in Holland is that they wanted to bill in a 15-minute interval. And so there was no way of growing these Excel spreadsheets by a factor of 4. It reached a level where it was not humanly possible to continue to work like this. So the business challenges for Uniper was to improve the response time to market. Meaning they, apart from looking at spreadsheets and lots of numbers, financially, they had to respond and validate the numbers within 9 days. If a mistake was made, too bad, money is lost. And also the decision to make a heat, a power, and steam, it depends on the performance of the assets as well as the price. So the value of the SigmaFind data in Uniper was getting it basically almost near real time. So they were getting the balance every hour with a 15 minutes, let's say, redistribution. Also, they also had another constraint, which is their heat loss to the environment, which also needed to be validated. And if you do it in a bad way, you can be over or under declaring how much heat you're losing, as well as your penalties. So what was the solution? What did the solution look like? They're a Pi customer. They already had the steam tables, they had Pi data link, etc. Everything on the left was already in place. And what we did is on the right. And so SigmaFind comes with its own PiAF to build the model. In this case, it was a linear energy balance hourly. And we also integrated their financial data. And so this is their fiscal data. So they bought gas at different pressures, and they were selling heat and power in many of the plants, and an industrial plant also sold steam. So the process of moving from raw data, time series data to financial data had a process. So we are collecting the data, we are validating this data in terms of we don't want to use processed data that is frozen, it's above a maximum or a minimum, if it's a negative, etc., etc. Not everything was metered, of course, in energy, so we had to convert temperature, pressure, etc. In some cases, we had to use valve positions. So let's just say that the data doesn't have to be a meter. It can also be an engineering estimate. Once we collected all of this data, the measurement data, the engineering estimates in terms of using valve positions or losses, etc., from the assets or to the environment, we are able to create a robust model that we can then create a data set which has high accuracy that can support their billing and trading. As a result, like I said, we gave them a better estimate of their losses. They had the energy balance is satisfied throughout the model, from going from gas to steam, electricity, and heat. And we also give them data quality indicators while they are not using it in terms of visually, because we have thousands of data points. Again, we were using Pi notification to use these statistical indicators to give them a list of the high impacting measurements that were unreliable. The model looked on the left, you can see assets which are probably familiar. There's an HRSG. We have a steam turbine on the back. In the front, we had the gas turbine. Here we have these are some other gas turbines here, etc. And we were selling some electricity, etc. So you guys are, let's say, the experts. I had never worked in power except for this 2-year project or year project that I did. So we moved Uniper from a manual validation to automatic. Everything, there's no SigmaFind user. A SigmaFind, we put the integration framework in, it collected the Pi data natively, it collected the financial data, it runs the balance, it publishes the data to their, let's say, their financial system. There they can accept or ask for a rerun if they are not happy with the data quality indicators, and then they get an email on which measurements they should pay attention to. So when the project was finished, SigmaFind became really an infrastructure that they don't even use the screen. They use their emails and they go to the problem areas. So everything went from manual to automatic, even the detection of faulty meters. In a nutshell, what did this bring to Uniper? They expected to save 300 to 500,000 K annually, but that's not a number I would quote without context, because this is for 4 sites. It's related to the megawatts. So it was 4 sites, a lot of megawatts. But what they said, which I think is of value to who's listening, is that using the SigmaFind to get better data and also to identify where your processes are inefficient, they expect to save 4 to 6% of the heat that they sell to the market, because most of their imbalance uncertainty was on the heat. So this is what we were able to do for Uniper, really taking them from Excel. Both Uniper and ArcelorMittal were stuck in Excel and spending a lot of time. The resources, very highly skilled resources, were caught up in Excel, and now they are caught up in using their skills to improve the performance of the company. And now I will stop sharing and I will hand over to Marco, my colleague, who is the industry principal for this industry. Thank you.
Thank you, Felicia. Okay, let's share the screen. Okay, we will introduce a few use cases, both in refining and in chemicals. So let's start from the first one. Okay, the first use case comes from Orpik. Orpik is a large refining and petrochemical facility in Oman, so in the Middle East. They are using SigmaFind since a good number of years now. For them, let's say the most value that got out of reconciliation and from using SigmaFind was, of course, the first driver was doing production accounting, loss identification, so identify better root cause losses in the refinery. Using indicators provided by SigmaFind, also improve the device maintenance, so spot where problems in the data were due to misconfiguration or wrongly problems in the measurements, so identify where to do recalibration or supply different instrumentation. Improve the overall data quality, get better measurement, and in the end, have a platform for a full data validation of their facility. If you can go next. Okay, here are some of the numbers they exposed to us. So along the years, a reduction in the uncertainty of the measurements. Here they achieved a lot of reduction from a 17% to 3%. A better agreement between planning data and actual data after, so they were updating their planning system with the better data provided by SigmaFind, so to achieve a better agreement along the years. And last but not least, even a great reduction in fuel and losses, so the yellow one. So they achieved a 2% reduction over 2 years, which is really a major reduction, also in terms of value. Okay, let's go next. Next slide, please. Okay, the second case is from Chevron. And here we are sharing with you their operational intelligence dashboard, which is receiving data from Pi and SigmaFind. And they created this web-based refinery scorecard where they can monitor and have alerts about the different process units, how is the data quality. So is green, yellow, red. And so they know exactly where to act, both from a balance point of view, but also from an agreement between planned and actual data and the yields of the unit as well. The next one. Suncor Energy is a company in Canada. Here we are showing their dashboard, which was created with Tableau, which is reading SigmaFine results. In this case, they are using composition tracking analysis. Composition tracking analysis is something that you can place on top of mass balance in order to track materials from the origin to the destination. In this case, we are tracking the different crudes from the receipts through the crude storage tanks till the feed. Through this dashboard, they have a clear understanding of how much material is stored per material type and where it is stored by tank. So better improvement in the way they are handled. Last use case from refining point of view comes from Lukoil, and here are two examples of web reports. So again, data coming out from SigmaFine analysis. Again, here is a combination of mass balance and composition tracking, are then exposed. Vidisha mentioned before, we have a SQL way to expose our data, and from there we build these daily reports where we can have an aggregated view of a SigmaFine datasets. Okay, the next one. Coming to chemicals, okay, we can go on. Okay, the first case is quite particular. It was done together with Eni Versalis, which is the chemical branch of Eni. And we implemented a new SigmaFine analysis, which is quality tracking, an analysis that allows to improve estimation of physical properties based on material transactions. Their objective was to improve the way they were planning the receipt of materials and the handling of the aromatic plant they have. Next one. So we implemented this algorithm that is tracking on one side the blends of materials, that you can see on the histogram below. This is 1 month of data. Based on the type of materials and the associated properties, we estimated in places where either there was no measurement or the measurements were available only days after, because the lab had to analyze the sample and then report back. So they had instead an online monitoring tool to estimate the composition of the materials and of the blend that were going to be processed. So you know which charge, the composition of the charge of the aromatic plant, and so what to expect in terms of production of benzene, toluene, and xylene. We go to the next one. So in the end, the benefit they achieved was double. So on one side, better operational. Sorry. So better operation because they knew could estimate better the unit yield in near real time. So better operation of the plant. On a longer term, a better scheduling, planning and scheduling, because they knew exactly how the plant was behaving and which kind of materials were stored in the tanks. So they could improve the way they were purchasing materials, reduce the demurrage costs, maximize the ship loading, and overall optimize the logistics. Next one. Okay, final example, instead is on the energy side. So this is a case of an ethyl benzene styrene purification column in a styrene plant. This column was highly imbalanced from both on a mass and on an energy basis. So the KPIs that were used were strongly affected by this imbalance. So they were not that reliable. So the scope of SigmaFine here was to improve the reliability of such KPIs. If you can go to the next one. So you can see the model here. We were retrieving data automatically from the PI system. The model was running every 10 minutes where we were applied energy balance, thermodynamic extension to support the enthalpy calculations, steam tables. And everything then was streamed automatically through a typical layer that was then feeding a business intelligence dashboard, which was available both to the operators in the control room and to the energy manager. Next one. Okay, here we have a comparison of what we obtain between raw and reconciled data. So the reconciled data are the ones provided by SigmaFine and that are consistent with the mass and energy balance. And if we concentrate just on the last one, we discover that the specific consumption of the reboiler was much higher compared to what they were thinking of. So we discovered an operational gap that was quantified at the time in about 2,000 euros per day of missed revenues. So based on this information, then they changed the way they were handling the column. So reduced a bit the heat load, whilst at the same time still keeping the product in specification.
Thank you, Marco and Berisha, for your great presentation. So we are at the end of our part. Okay, here is just to give you an overview about a bigger picture. So how to link in data to business outcome. And so as you can see, SigmaFine is a layer between the data and that you acquire for the field. So if you think about the data that can be stored in the PI system and the calculation of KPI performance and metrics. So through SigmaFine, we want to generate a validated data set in order to share this data with a higher quality to the next level. So here is a short summary of our presentation. So as you saw in our presentation, SigmaFine incorporates measured and financial data to provide accurate and actionable operation data. So, and SigmaFine can monitor the measurement data quality and provide an auditable process. And our solution has an infrastructure that is scalable and configurable. So it can grow both in dimension and capabilities to meet the business needs in the different industries. Thank you.
Okay, thank you so much, Gabriel, Dr. Berisha, and Marco for your very comprehensive presentation of what SigmaFine can actually do in the revolution of industries through data management and enhancement. So indeed, that would lead to different breakthroughs to different essential industries as well, not just today, but more so in the coming years, where there would be more advancements. So of course, for us to maximize the presence of our subject matter experts, we actually have 4 in this call. We will address some of your questions. So feel free to send your queries through the link, through the QR code on your screen, and probably through the chat. So you can just send your questions in here. We have quite a few questions. Let me read one. So there are these questions in here. We have adopted the PI system, but not all the data are available in the PI system. So is it possible to access to this data from SigmaFine? So it might be Gabriel who would want to answer this question.
Yes, thank you, Elsarin. So yes, so SigmaFine as an application that is named Integration Framework. So thanks to the integration framework, we can connect Sigma Fine to other IT solution. And set Sigma Fine based on Pi technology, we can connect directly without the interface to the Pi system.
Okay, so we have another question. Okay, so can Sigma Fine estimate unmeasured flows and or inventory? So probably this would be the last question that we will be raising this afternoon. Can Sigma Fine estimate unmeasured flows and or inventory?
Okay, I'll take that one. So yes, it depends on the level of robustness of your model. So once you have a high redundancy level, let's say more than 85% of your measurements are known either by measurement or by estimation, the other 15% of measurements are rule of thumb, in principle can be estimated, whether they are inventory points, so tanks, or etc., or are flows, which have meters or missing meters or missing analyzers. Because to solve a balance, Sigma Fine is taking this data set, and it's for all connected flows and inventories, it's giving you a data set that adheres to the conservation of mass, energy, volume components. And so yes, it's one of the key benefits of Sigma Fine in any Sigma Fine project is that let's say the blind spots are you now have an estimate, and pretty reliable too, because you do get a data quality indicator telling you how reliable this estimate is. We call them pseudometers.
Yeah. All right. So thank you, Felicia and Gabriel, for answering the questions. For those who still have queries, you may still type in your questions through our QR code. We also have the event feedback form on your screen, so you may also scan that for us to get your feedback, and probably you have suggestions on what you would want to hear from us in the future. So for the benefit of time, it's already 3 p.m. here in the Philippines. And I believe it's already 9 o'clock there in Milan, right, Gabriel? So there, thank you once again for everyone who joined us this afternoon. So should you want to connect with us, feel free to connect with the point persons on your screen. That would be Wesley Belbido from Calibrate and Gabriel Marazzi from Sigma Fine Timsoft. So thank you once again, everybody. Thank you also to our very informative speakers, Isamu, Felicia, Gabriel, and Marco. Thank you very much, Timsoft and Calibrate. Good afternoon. Thank you.
Thank you.
Goodbye.
Bye.
Thank you, everyone.